Dear aspirants, welcome to my channel. This is an model question paper 2, electrical and electronics engineering, semester 2, concepts of electrical circuit. Subject code is 25 EE21 high. So 5 marks part D, section 1, 5 marks questions. If you attend 5, you will get a 25 marks. The question is, with a neat sketch, explain electrical field, electrical flux line between two charges. Okay. So before going to what do you mean by electrical field? So it is a region around charged body where the another charged body experienced by force, that we call it as an electrical field. In an electrical field lines showing a direction and strength of the field. So direction of the line from positive charge to negative charge. In that field lines between the like charges like positive and negative, if the field line starts from positive charge and end at negative charge, okay, the line crowded near charges showing a strong field intensity. These patterns represent electrical dipole. Arrows indicate the direction of the force on positive test charges. You just see this is the diagram between the like charges, positive and negative charges. This is the electrical field which will be induced. This is the diagram, electrical field which will be induced. Okay, this is the diagram we have to write. Next will be field lines between like charges, positive positive or negative negative. So I'll show the diagram between the like charges, positive positive and negative negative. So this is the diagram which will represent like charges. Both will be in positive. They are going to represent. So I just explain what is. I'm going to explain this. In the field lines, like charges do not meet each other. By seeing only, you can classify lines bent outward due to repulsion. It will not be attract each other, and there is a weak field region at the center between the charges. Okay, the field line never cross one another. So this is the features of like charges. And next extra important point. So the first one, electrical fields is a force experienced by per positive charges. Coming to the electrical flux lines represent electrical field patterns. So flux lines originated from positive charge terminated at the negative charge. Same way closer lines indicate the stronger electrical field, and electrical field lines never intersect each other. Next question, explain the phenomena of self-induced EMF with a neat with a diagram. So before going to that, what do you mean by self-induction EMF force? Electromotive force, which we call it as an electromotive force. So where it will be induced? Electromotive force induced in a coil due to charges of the current in the same coil, that is we call it as a self-induced quantity. Same coil only, it will be induced. It is according to Faraday's law, the changing flux induced EMF force in a same coil. Coming to the diagram. So this is the diagram. This is the coils, the current which passing and switch and battery, and EMF force, it is called flux lines. EMF force induced. This is we call it as an EMF force. This is the diagram. You can write it in the exam. This is the diagram and force. This is the diagram. You can write it. So explanation part of the diagram. Consider a coil connected to a battery and switch. Next, when a switch is closed, current start increasing in the coil. So increasing current produces a changing magnetic flux around the coil. This charge flux induced EMF in a same coil. The induced EMF opposed to change in current according to Lenz's law. Okay, the EMF is called back EMF or self-induced EMF. Next, the greater rate of change in current, greater induced EMF. Same as self-induction, you can use it for transform, chokes and inductors. We are using this one. Next, explain grouping of cells for a required voltage and current. So grouping of cells for a required voltage current. First we should know what you mean by grouping. So grouping is a connecting with a two or more cells together to obtain the required voltage and current, that we call it as a grouping of cells. In this grouping there's a two types. One is a series grouping of cells. In that series grouping of cells, in the series grouping, a positive terminal in one cell connected to negative terminal of a next cell. Okay. Total voltage is increased, current capacity remains same in one cell. Okay. Used when high voltage required, total EMF is equal to E1, E2, E3. That is series. This is the diagram which will be an arranged in a series, battery and lamp which is arranged in the series. Okay, this is the diagram for that. Next will parallel grouping of cells. In a parallel grouping, all positive terminals are connected together, all negative terminals together. The voltage remains same as on cell. Current capacity will be increased. Used when a large current required. Cell lost longer parallel connection. This is the diagram for parallel. The cells are connected in a parallel. The battery is connected. This is the diagram. And important point, series grouping increase the voltage, parallel grouping increase the current capacity. The group of cells which will help you to obtain the electrical output. Batteries in vehicles and electronic devices used for grouped cells. The proper grouping improve the efficiency and performance. Okay. So if the content is useful, please subscribe my channel and share and support. So remaining questions I am going to upload next video. Thank you.